Okay, today we're going to be talking about angle of muscle pull. So before we start talking about it, I want to define what the angle of muscle pull is. And then we can start talking about the different components of it and problem solving with these problems. So the definition of angle of muscle pull is the angle between the line of muscle pull and the bone that muscle is inserting on. So if we remember, the line of muscle pull always goes starting at the insertion point. So I'll draw the line of muscle pull in this first diagram. It always starts from the insertion going up towards the origin, and it's basically in the center of all the muscle fibers, because that's where all your muscular force is going to be centered on. So the angle of muscle pull is between the bone the muscle inserts on, so this bone, let's say that this is the ulna and this is the humerus, and the line of muscle pull. So you say, well, there's two angles between the line of muscle pull and the bone, and you're right. But for angle of muscle pull problems, you always want to draw the angle on the joint side. So let's go ahead and draw the angle of muscle pull for each of these examples I've drawn on the board here, just so you can get some practice, because this is crucial for being able to do these problems so you don't get confused. So remember, the line of muscle pull and the angle and the bone upon which the muscle inserts on the joint side. So here we have an angle here, and that is a 90-degree angle, so I'll make that the 90-degree angle sign. And then here, the line of muscle pull, we'll draw that. So starting from insertion, going up to origin in the middle of the muscle, between the bone and the line of muscle pull on the joint side, so not here, but here. So you can see that that angle is less than 90 degrees. Then again here, line of muscle pull, insertion to origin, and between the bone on which the muscle inserts on joint side. So here to here. So you can see that that angle is greater than 90 degrees. Okay, then the second part of doing these problems is drawing the resultant vectors, breaking it down into rotatory component, a stabilizing component, or a dislocating component. So when your angle is 90 degrees, by definition, all of your muscular energy is going into rotation, or the rotatory component. And you can kind of see that here, that all the force is going exactly perpendicular to the bone, because this angle of muscle pull is 90 degrees. So that's 100% rotatory. Okay, now here, remember that rotation is the force that's always perpendicular to the bone. So let's draw that component here going from the point of insertion, and I will draw my resultant vectors up to here and see what happens. So I'll start it from here, try to make it as best as I can without a ruler. That wasn't very good, but you can see the point. So that is my rotatory component, because that is perpendicular to the muscle of insertion, or to the bone of insertion. Then my other vector, to complete my vector analysis, is to the top of my muscle line of pull. So this is my rotatory component. So some of my muscle is acting for a rotation component, but some of it is also going back towards the muscle. And this should be exactly parallel to the insertion, but I don't have a ruler or anything. And this, you can see that this force, if we move this arrow down here, it would be pulling the bone back towards the joint. So that would be defined as a stabilizing component. So anytime the angle of muscle pull is less than 90 degrees, you have a stabilizing and, the plus sign kind of looked weird, and a rotatory component. Okay? Now let's do the same thing for this angle, where the angle is greater than 90 degrees. Let's draw my rotatory component starting from the insertion point, running exactly perpendicular to the insertion bone. Then we'll draw the last arrow for the resultant vector of the muscle line of pull. if we brought this arrow down again, you can see that there is a force that is causing the bone to want to dislocate from the joint, and that's why it's called the dislocating component. Okay, so anytime your angle is greater than 90 degrees, you have a dislocating component. One more cool thing that you can kind of see is looking at the length of these arrows, you can see which component is greater. In this case, you can see that the length of the rotatory component is longer than the stabilizing component. So most of your force at this specific angle is going towards rotation. Well, I shouldn't say most, but more is going towards rotation than stabilization. Here, the lines, they're pretty much similar in length. This one looks a little bit bigger, so again, the rotation factor is bigger than your dislocating component. And that's the gist of line angle of muscle pull.